All right, welcome back to Burt's Basics. So we are tackling now erythrocytes found in the blood. Now this is probably going to be our longest video, so just kind of do the best you can, and let's just kind of do one piece at a time, and we'll see how well we can do on this guy. So here's what we're going to start off with. Okay, just a couple notes on erythrocytes so you know what they are. Remember, erythro is your red. So these are your red blood cells. It says they make up 95% of the formed elements. That means they are the majority of the cells found in our blood. But I want to go into what they do. If you look at a red blood cell, they're very unique in their shape and their appearance. If I could draw them from the side, okay, I can't draw them in green, I got to draw them in red. They kind of have this really cool flexibility, concave disc like this, where they are kind of like, look like a donut or very hollow in the center. You can kind of see they have this depression, can't do red on red. They have this depression here in the center right here. And the reason why they have that is because as they mature, they kick out their nucleus in every other organelle. So if they don't have a nucleus or a mitochondria, oh, that's horrible. If they don't have a mitochondria, well then what do they have inside them then? Inside of red blood cells, they have this mighty guy. Now you better learn to love this guy, you better be with him, you better understand him 100%. Let's start with the blue first, okay? The blue is this. Okay, whenever you see that in the world of biology, that is always going to be a protein. So whenever you hear that, that's going to be a protein. Now these are made up of a series of proteins. You have 2 alpha chains, you have 2 beta chains. So if I'm really going to draw this, I'm going to draw 1 protein, 2 protein, 3 proteins, 4 proteins, and then kind of link them all together. Okay? Whenever we have a protein like this, we call this a globin or a globular protein. So that's the globin part. Now let's switch to red. In med term, you guys have learned that heme refers to blood, which is pretty good. But in chemistry, heme with an E on the end refers to iron, which is where heme gets its name from. This is a heme group, an iron-containing compound. This is iron. That represents the red flying saucers. So this is a heme group, or an iron, an iron, an iron, and an iron. That is the heme part. So when they first saw this, they're like, man, check out this really cool compound that red blood cells have. What should we call it? Well, they have a heme, and that heme is stuck on a globin. So what should we call it? Ooh, I got an idea. Let's call it a hemoglobin. Now, this is a misconception. Everyone thinks this is so massive that there's only one hemoglobin inside of a red blood cells. There are millions and millions and millions of hemoglobins in every red blood cell. Now let's get to the aha. Why does it matter? It matters because these flying saucers, okay, these heme groups are the ones that are going to attract oxygen. They are the ones who carry oxygen and give it its red color and make it by the heaviest element. So when your centrifuge is at the bottom, red blood cells carry oxygen. 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 Oh, there's something else I wanted to say about them. What else? Oh, that's right. Red blood cells carry oxygen. That's what you need to know. They carry oxygen. Now, guess what? White blood cells don't have iron. So guess what? They cannot carry oxygen. Platelets do not have iron. So guess what? They cannot carry oxygen. Red blood cells are your oxygen carriers, and they contain hemoglobin. Now this should make even more sense. Mitochondria use oxygen. So if I was trying to carry oxygen and I still had a mitochondria, I would use my own oxygen that I'm carrying. But I kick out my mitochondria. That way there's nothing inside the red blood cell that can use that oxygen. So he can carry that valuable oxygen to all the tissues in our body. Okay, erythrocytes, hemoglobin, a huge, huge concept of erythrocytes. Make sure you understand that really, really, really well. Okay? Okay, skip past white and platelets for a second. Now let's go to more red blood cells. Okay? You guys know this. You know your ABO blood type. Now, it might be a long time ago since you guys have done this. Can I go ahead and start with something that might be a little easier for you guys first, if I could? Okay. If you zoom in on a red blood cell. All right, so let's go ahead and talk about this really quick. Just make sure this works. So when we talk about red blood cells, okay, red blood cells, they are a cell, and they have receptors on the surface of that cell. So if I ask you to give me every blood type on planet Earth that you guys know, could you give them to me? There's type A, there's type B, there's type AB, and my personal favorite, type O. That's what I am. So I'm going to put a little smiley face next to this one, okay? Those are the 4 blood types. Now, the tricky part on this is you have to understand how red blood cells work, especially the receptors on the red blood cell, okay? So when we talk about a cell, we always drew a little cactus, and we always call that a receptor. Now, in this class, I'm going to give you a different word for receptor, and I hope it doesn't freak you out too bad. We actually going to call this, in this class, an antigen, okay? An antigen is a receptor that has to deal with immunity. Okay, so there is a difference between a receptor and an antigen, but in this class, we're going to call them the same. So I'm going to call this an antigen. So now let's go ahead and go through this. Okay, if I have a red blood cell, and I know Dad can give me a gene for my blood cells, and I know Mom can give me a gene for my blood cells, okay? And I know there's 4 different types. There's A, B, AB, and O. Well, what happens if they're different? What if Dad gives me an A and Mom gives me an O? Well, this is where you got to do some simple genetics. A is dominant to O. So what happens if this is your blood type? AA or AO? Well, it doesn't really matter because then you will be blood type A. What that means on our cell surface means you have the receptor, and that receptor is an A antigen or an A receptor. That is type A blood. So now let's switch this up a little bit. What if Dad gives you a B? Well, guys, guess what? B is dominant to O. So what if your blood type is BO or BB? Well, then congratulations. You are now type B, which means if I look at your red blood cell, this can no longer be. Haha, no longer be. Get it? I'm funny. You still have a receptor on here. You definitely have a receptor, but instead of having the A receptor, now you have a B receptor. And that is type B blood. So now let's do the craziest of one of them all. Okay? What if, give me my eraser. Thank you. What if Mom gives you an A and Dad gives you a B? Ooh, that's kind of tricky. Well, guess what? A and B are what we call co-dominant. They're co-captains. So if you're type AB, or get an A and a B, then you are type AB. So if you look at the red blood cell, not only do you have the B receptor, but you also have the A receptor. So you actually have both of them. So now here's the real question. What happens if you don't have an A or a B, and Mom gave you an O and Dad gave you an O? Well, what happens if I'm O? Then what blood type am I? Well, then I'm type O. O is what we call recessive. O. So guess what happens if you're type O? You cannot have the A antigen, and you cannot have the B antigen. So your red blood cell looks like that. Now, if you look at this, you're like, oh my goodness, it has no receptors. It does have receptors on here. Okay, they always have receptors, but it doesn't have the A or B receptor. So can we do a quick test run just to make sure you guys get this mastered? So here we go. Let's erase this and try again. You ready? Test run. What blood type am I? The answer? A, because you have the A receptor. Let's make it tricky. Now what blood type am I? Well, let's see. I have the A and the B, so that means I show them both. So that must mean I'm type AB. Ooh, tricky, tricky. What happens if this is my red blood cell? Now what blood type am I? Well, I only have the B receptor, so now I'd be type B. Okay, what happens if I don't have either of those? Well, if I don't have either the A antigen or the B antigen, that must mean that I am type O. Now, hopefully, just that little review will help this chart make way more sense. Check it out. If I'm type A, I have the A receptor, which is the A antigen, and you are type B. Type A. If I'm type B, then I have the B receptor, or the B antigen, and then I'm type B. But if I'm AB, check it out, I have both of them. So that means then I'm type AB. And if you're type O, then you don't have either of those. Now, if you look really close, I kept saying the word antigen. This is more important than you can imagine. These are really tricky questions. Since I have the A antigen, okay, that means every one of my cells should recognize A as me if I'm type A blood. But then I make what we call an antibody. An antibody is a free-floating protein stick that will attach to things and prohibit their motion. So if you notice, if I'm type A blood, I make a B antibody. That should make sense because if I'm type A, I should never have a B inside me. If I'm type B blood, I make A antibodies. I fight against every A that I'm ever going to encounter. If I'm type AB, they don't even make any of the antibodies for either of them. Now think about it. What if they made an anti-A? Well, then that would kill them. What if they made an anti-B? Well, that would kill them. So they don't make either of them. Now type O blood, my blood, check it out. I make every antibody on the planet. So let's do a test run. Me. Let's say I'm in the hospital and I'm really struggling. And you, as an incompetent nurse, give me type A blood. Well, what happens when I get this type A blood and I see the A receptor on here? Well, I make anti-what? A antibodies, so I'm going to kill it. What if you give me type B blood? Well, guess what? I'll kill him too. What if you give me AB blood? Guess what? I'll kill him twice, okay? So if I'm type O blood, the only blood I can get is from a type O person. Now, let's talk about AB though. AB rocks. What happens if you give me type B blood? Well, guess what? I already have B, so I won't fight it. What if you give me type A blood? Cool, guess what? I already have A, I won't fight it. What happens if you give me type O? Cool, there's nothing even to grab on type O. So we usually call ABs universal recipient, and type O is universal donor. Okay, that's blood type 101. But there's one more antigen we got to talk about really quick, and that antigen is called the RH antigen. Okay, so what we found out is these red blood cells, okay, I'm going to have to do them in a different color here. Not only do they have the A and B, well, you can barely even see that. Let me just do a new screen really quick. Not only do they have the A and B antigen, but they also found another receptor that we call the RH antigen. Okay, RH stands for rhesus, named after the monkey. Okay, so guess what happens? Positive is dominant to negative. So guess what happens if this is your red blood cell? So once again, here's my red blood cell. Well, I'm type A because I definitely have the A receptor. But then guess what? Since I have the RH, now I'm A positive. Check this out. This is like a magic trick. What if I don't have the RH factor? Well, now I become A what? Whoops. And now I become A negative. So let's do a test run. What am I? Okay, well, let's see. What receptors or antigens do you have? Well, let's see. I got the A, I got the B, and I got the RH, so I am now AB positive. Can I show you my red blood cells, by the way? I'm this. Wait for it. That's me. I'm about as boring as they come. So what is my blood type? Well, I don't have A, I don't have B, so I'm definitely type O, and I don't have the RH factor, so I'm O negative. Which means my blood is the coolest blood on the planet, because you can give my blood to everybody. There's nothing to fight on my O. I don't have any RH to worry about. My blood rocks. Okay, now we didn't get into diseases on red blood cells, but I think we got the main idea of blood cells and blood type. So thanks for watching Burt's Basics, guys. Come back and watch them often. See you on the flip side.